We thought we'd bring in someone who has expert knowledge of this in terms of what the implications might be for that piece of infrastructure following this M1 highway fire. And I'm joined by Professor Richard Walls, who is with the Structural Engineering Division at Stellenbosch University's Department of Civil Engineering. Prof. Walls, thank you very much for joining us this morning. Really do appreciate your time. When you see an incident like this happen, and notwithstanding the fact that the City Power spokesperson said they've still got to get their engineers in there to really do a proper assessment, what types of things would they be looking out for?
Good morning to the listeners. So, firstly, you need to know what the geometry is of the section. From what I can see of the pictures, it looks like you've got your main M1 highway road, and then adjacent to it, some sort of tunnel, which I think is doubling up as a walkway. So it's possible, for instance, that the tunnel could be compromised while the bridge is still fine. It depends on whether they are sort of integral or two separate pieces. And then also they've got to look at how long the fire lasted, but not just that, it's how intense the fire was, how hot it was, because it's very difficult to know exact conditions underground. One of the most dangerous things is when you do have a longer lasting fire. So a short hot fire is more dangerous to steel, but a longer cooler fire is actually more dangerous to concrete because it expands and then you can actually have the concrete crashing. So there's got to be some material testing, visual inspections and various things done to understand what has lost strength, and then how, if it has lost strength, what can be done to bring it into service.
Walls, Professor Walls, that's so fascinating, because my next question was going to be around temperatures, and we think about the steel reinforcements in infrastructure like that. I mean, you see buildings get built all the time and they have this kind of meshing, steel meshing that gets in, and then the concrete gets poured inside. And you would think a longer fire, would affect the steel in the structure more than the concrete. But you're saying this longer hot fire, and we understand this went on for about 24 hours, would then also affect the concrete. How does it alter the properties of concrete in a setting like that?
When I say concrete, I mean reinforced concrete. So you've got both concrete and steel. But for instance, steelwork only starts losing strength above 400 degrees Celsius, but most of it is regained. Concrete, though, is a good insulator. So what happens is it protects the steel, and so the heat takes a period of dozens of minutes, hours, depending on the intensity of fire. So concrete starts losing strength sort of 100 degrees and above once the moisture is driven off. But the thing is, normally your outer 5, 10, 20, 30 mils loses its strength, and then the inner part is protected. The most dangerous part with structural damage, and this has caused collapses of other buildings in Joburg and around, is when it heats up, because as it heats up, it pushes out and it exerts very, very high forces. So it depends on what heated up. And it's those forces that causes the damage to the structure. It's the thermal expansion when it can't go anywhere. If it's free to expand, it's normally fine. But when it's held in place and pushes out against other parts of the structure, you can crush concrete, you can buckle steel. You need to actually get down there, do inspections, do some testing, and analyze what's happened, but also based on a knowledge of what the geometry of the structure is.
I mean, so some of it would be obvious. They would get a visual on some bent concrete or a bent structure. You'd see some steel maybe peeking out. That's what I'm understanding you to say, correct?
Well, normally if the concrete has stayed intact, it depends. You may get spalling, so that's when the concrete pops off and then the rebar is exposed. But even if the concrete doesn't spall, the steel inside might have lost strength, but you'll start seeing the color and the form of the concrete changes. So there's ways of assessing it. At certain colors, different things happen. Also, what you can do is have a look at the damage in the area. So what has melted and what hasn't, and that will give an estimate. I mean, my guess of temperatures in the duct would have been somewhere between 600 and 800, maybe up to 1,000 degrees Celsius, because that's what you need for flaming temperatures and the sort of smoke produced. However, that would have occurred initially, and then if it was very ventilation starved, it might have become quite a cool fire inside, just producing lots of smoke. So it would depend on how much ventilation was able to get to where the fire was and how much fuel was available, what temperature you would have had long term. But initially it would have been many hundred degrees Celsius with the flaming.
Your field is it's very interesting and fascinating, and I really appreciate the simplicity with which you've put some of these things across. Okay, so they're going to get their engineers in there, they'll make an assessment. If there has been the threatening of that integral infrastructure, what would need to be done? Would it need ground-up restoration, or is there a way to build on the existing infrastructure?
It depends on how much has been damaged. So as I said, I'm really, really hoping the main spine of the M1, which carries cars, has not been damaged to that piece. If, for instance, let's say somehow it was damaged, then you have to have a look at what has been damaged. For instance, if it's main tension reinforcing, especially if it's what's called post-tensioning, it's these high-strength steel cables. If those have been weakened, that's a beast, because they slacken, and then you lose strength permanently. However, if it's cast in rebar that's been strengthened, that's easier to bring alongside. Maybe you have to just put in some carbon fiber or something like that to strengthen up. Maybe you can prop it, get some props in below, and then you can bring it back into operation quite quickly. I'm hoping that there'll only be limited stopping of traffic, but once again, it depends where it was, and I'm hoping it's the sort of to the side, so it's only the pedestrian walkway that gets cut out. But if it is the main highway, it could be 10 if it's propping, relatively quick, but if you have to start doing main structural strengthening, especially if it's your post-tensioning, that could be an extended period of time.
And it would be such a pity, because we know that there were extensive upgrades done to that piece of highway. I think it took between a year or two or so, so it would be so regrettable they'd have to go back and do extensive repair work on that bridge and that part of the highway. But appreciate you taking shortly from your classes and talking to us. Thank you so much, Professor Richard Walls, structural engineer in the Structural Engineering Division at Stellenbosch University.